Welcome, and here we're having a screencast on past paper questions on graph theory, and here's a question from January 2013.
Ta-da! I bet you thought it was Andrew doing this one, but it's actually me. And it's not even a screencast, it's a video. Lucky you. Now the fun's out of the way, let's get on with this. Only joking, of course, this is fun as well. So, a simple connected graph X has 8 vertices. Now, the most important thing about graph theory questions is you to make no assumptions and read the question. That might sound like an obvious thing to say, but I want to automatically be drawn, I want you to be drawn to this description here, okay? The way you are going to be able to answer graph theory questions is if you understand the terminology, okay? That's where you've got to focus your revision. Do you know what simple means? Do you know what connected means? And do you know what complete means? Those 3 terms are key to these questions. So, a simple connected graph X has 8 vertices. State the minimum number of edges of the graph. So, simple means, okay, I want you to think about that. Press pause. When you're happy, press play again. Simple means no unnecessary edges, okay? So you're thinking no loops, no double edges. Connected, we've got no vertices off on their own. We've got every vertex is connected in some way to the graph as a whole. So you can get from one vertex to any other, not necessarily directly, but you can do. So what you should be imagining here is a minimum spanning tree. Okay, so all the work we did on prims and cruscles is about finding that minimum spanning tree. So what do we know about a minimum spanning tree? Well, if we've got 8 vertices, how many edges have we got on a minimum spanning tree? 7. Okay, so that is 7 there. Find the maximum number of edges on the graph. So we've gone from minimum to maximum. So again, we need to come back to make sure we know what this means. It's connected, but now we want lots of edges. We want as many as possible. So at what point does however many we've got become too many? When it breaks one of these. In order for it to be connected, we can't break it with adding more edges. It's still going to stay connected. We then therefore need to look at simple. At some point, extra edges are going to stop it from being simple. So I want you to imagine what this looks like, a graph, as we're adding edges. At which point does it stop being simple? So I want you to be thinking, therefore, of loops, double edges, things like that. Okay, so what kind of graphs have as many edges as you can, but no loops? And that's where we get into the 3rd term, which we haven't got written here, but that's complete. A complete graph is a simple graph, and it's the biggest a simple graph can be. It's got the most number of edges. So we want to find the number of edges on a complete graph. Now, you are required, therefore, at this point, unless you want to draw an octagon and join line, which you could do. It wouldn't be a particularly good use of your time for 1 mark, but the best bet is to remember the formula, okay? So again, I want you to see if you can do that. Remember the formula, write it down. Press pause if you think it's going to take you a bit of time to do so. Okay, now that formula is n over 2 times n minus 1. So in this particular case, n is 8, so we've got 8 over 2 times 8 minus 1. So we've got 4 times 7, so we've got 28, okay? Now, just to spend a little bit of time talking about that n over 2 times n minus 1, that might seem familiar. In fact, it should seem familiar, because that is also the formula in sorts for maximum number of comparisons for shuttle, bubble, and quick. Now, you might think, oh, do I have to remember if it's which ones it's for? Well, no, not really. You have to remember that if you are asked maximum number of comparisons, that's the answer, because it's the same for all 3 and you're never going to be asked it for shell. So all you need to know is if it talks about maximum comparisons, it's n over 2 times n minus 1. And because it's the answer to that, and it's also the answer to this, what I want you to do is, in the terrible scenario that you've forgotten all of this, that needs to be your go-to. That needs to be your guess. Rather than blank, if in doubt, go n over 2 n minus 1, because your chances, I know this isn't a probability, this isn't statistics, but I'm going to bring it in here, your probability of getting this correct is better if you go for the one which is right for more questions, n over 2 times n minus 1. So obviously, I want you to know what all these ones are, but if in doubt, that is the key one, okay? So that's 28. So moving on, a simple connected graph has, Y has n vertices. They love doing this. They ask you it with numbers, then they ask you it with ends. Personally, I think it's a bit redundant, because chances are you can't do this unless you know the ends. In fact, it probably would have made more sense to have them the other way around. This allows you to get the marks if you draw an octagon and draw lots of lines. But chances are, if you've got that right, it'll be because you know this. So how did we get from 8 to 7? It's because we knew that it was n minus 1. Okay? So this